you kind of are careful with, like, if you're comparing it to a series, make sure you put like the little sigma in front. If you're comparing it to terms, make sure you're just comparing terms. And then of course, make sure you are always aware of like what you have to show in order to justify convergence and divergence. Other thing I would say, even if you did well, I might recommend looking at the quiz answer key, because a lot of you, for whatever reason, want to find like the hardest way to prove convergence or divergence as possible. For example, there was a number of students who really loved the integral test, which is often one of the most inefficient tests to use when like the DCT or LCT is a lot more efficient. So for your own benefit, like even if you did well, definitely look at the answer key, because I tried to work it out in the most efficient manner, but then I did kind of put notes in my answer key of all the other tests that would have worked as well. Today and basically for the next week, so basically today through Friday and then including Monday, we're going to be building on this topic called a power series, which is going to lead us into, by the time we get to notes on Wednesday-ish, possibly Tuesday, but it's just kind of like a lot of stuff to get done. But by Wednesday, we'll kind of build this into this idea of what's called a Taylor polynomial or a Maclaurin polynomial. Before I just jump into today's notes, I did just want to kind of give you a function and just like, hey, let's talk about it, and then kind of see where we end up with it and kind of go into the various notes that we have today. So this is a polynomial. We know a polynomial is an expression that has terms that can be added or subtracted, and you basically have like x raised to a power, and that's what's going to make it a polynomial. Looking at this particular polynomial, if you notice, I did kind of put this ... at the end of it, because this polynomial is going on forever. It is a polynomial that has an infinite number of terms, which is what's going to have like a lot of unique properties and what we're going to basically be focusing on all this week. Like we're used to dealing with a polynomial that's like a trinomial, or one that has 4 terms or 5 terms, or maybe just a binomial with 2 terms. This one has an infinite number of terms. Why we're learning this kind of in this unit is, since it does have an infinite number of terms, it might be a little bit easier to write as a series. Like we know a series is created by adding up the terms of the sequence. Looking at this one that I happen to choose, I chose one that I want to be an easier one. What special type of series could you model this polynomial with? It is a geometric series. How do I know it's a geometric series? What are we multiplying by as we move from one term to the next term? X. So you can see like 3 times x is 3x, times x is 3x squared, times x again, 3x cubed. So we have this idea that our common ratio is literally the x value. Since that common ratio is the x value, I can use that to basically write a series for that function f of x. Doesn't matter where I started at. Like I could start at 0 or 1. I would just kind of like the exponent. I'm going to choose 0 because that's kind of the easier one to look at. This is an infinite polynomial, and I can write it in the basic geometric form. So I have 3 times the r value to the n. And I think looking at that, you can agree that that series would make that polynomial we'll see. Like we're starting at 3 when n is 0, times x, times x, times x, times x, basically forever. Since this is a geometric series, we actually know how to find the sum of a geometric series. What's the formula we use to find the sum of a geometric series? Initial over 1 minus r. Some people forgot that on Friday. So if I'm looking at this one, what was the initial term? 3. 1 minus our r value, which is x, which is going to give me this function 3 over 1 minus x. So like big overarching idea that we have kind of for this topic is we have a rational function, which is kind of like a complicated function, if you will. It's not like it has asymptotes. We can express that rational function as an infinite polynomial. So I do want to kind of look at this. This infinite polynomial you're looking at, it's not approximately 3 over 1 minus x. It is the graph of 3 over 1 minus x. To kind of help you see why that is, I'm going to use Desmos to kind of let us see this. So that is the graph of 3 over 1 minus x. Like, we know it's a rational function, it has an asymptote at 1. Here is what the first two terms look like. That was like n sub n is equal to 0 and n is equal to 1. What do you notice about that line? What's special about it in terms of calculus? It's the tangent line. So let's go ahead and do the first three terms. What are some things you notice about the first three terms? It's the quadratic, but what do you notice if you're comparing that quadratic with the graph of 3 over 1 minus x? And what I notice, and we'll kind of see, let's kind of see what happens as we add more terms. So here's the first 4 terms. Here's the first 5 terms. Here's the first 6 terms. What are we noticing? It's getting closer and closer. So like, bear with me for a second. Clearly I cannot sit here and type in an infinite number of terms. But what do you expect to happen as I type in an infinite number of terms? It approaches to where it actually becomes that graph. Now there are some limitations on when those terms will become that graph. And that's what I want to focus on today. So like the second half of the week, we're going to kind of actually figure out how to write the infinite polynomials for basically whatever function we want to write. Today we're just going to kind of focus on like how can we determine whether or not a given series is going to be the equivalent to some like known function, if you will. And for example, before we get into like all the vocabulary and the definitions and all of that, looking at this one is a geometric series. What has to be true for a geometric series to converge? The R value has to be what? Less than 1. Specifically, the absolute value of R has to be less than 1. So this series is only really equal to 3 over 1 minus x when what statement's going to end up being true? The absolute value of x is less than 1, or basically x is between -1 and 1. And that's what we're going to focus on kind of today, in like a whole lot more words and a lot more steps of like when we have these things called power series, how can we determine when they are going to converge, when they're going to diverge, and kind of like, do they have like a lot of, you know, how do I want to say it without knowing other words? Basically, like, what are they going to be valid for? We'll leave that kind of that for now. So what I want to go ahead and define is a power series, which we're not going to confuse with a P series. This is going to be the full name power series. And a power series is going to be any series written in the form. So it is a series, n is going to be starting at some number, and it's an infinite series. And it's going to be written as a sub n times x minus c to the n. What does a power series look like? A power series is always going to be equal to an infinitely long polynomial. If you were to expand it out, there are some key features of it that we will notice. This first part that I'm representing as a sub n is basically going to be your coefficients. So basically it's going to be like its own series of your coefficients. The inside, so we know x is in all of our polynomials, so like n is going to be like the degree that we have, the largest exponent. C is going to be called the center of that power series. The short version of what is the center, the closer you are to the center, the more that power series is going to model the actual function. So like in that previous one we did, we said the series was close to 3 over 1 minus x. The center of that one, and let me go back to it as I kind of talk about it. The center of this one, so I have x to the n, that's like saying x minus 0 to the nth power. Its center is 0, so it's going to be most valid at x values close to 0. The further you get away from the center, the less kind of valid, if you will, that power series is going to be, which we kind of saw it matched the graph closely around 0. The further away from 0 you got, the further off it looked. That format of a power series is going to be important to kind of recognize, because a common question, even on a free response question, it will say like, hey, what's the center of the power series? And you just want to look for what is that number subtracted from x, and that's going to be the center that you're looking for. So let's go ahead and look at one power series. And let's talk about how I know it's a power series. So this is a series where n is at 0 to infinity of this x minus 5 to the n over 3 to the n. Not necessary to expand it, but we can see that this represents an infinite polynomial, because you like have n is equal to 0, anything to the 0th power is 1. Then you have n is equal to 1, you have n is equal to 2, and that's literally going to continue forever. So we can see that that is going to create this infinitely long polynomial. Easy question to ask. What is the center of the series? And we can just do that by looking at the problem. What is the center of that series? Just 5. So sometimes it might be easier to rewrite it. The center is just 5. So again, if we think about all power series are always in this format, if you can manipulate your series to be in that format, then just look for what the C value is. So like writing this one in that format is the series. The coefficients are coming from that formula of 1 over 3n. And then we have x minus 5 to the n. We know that this one is centered at x is equal to 5. Again, what does that mean? At 5, when x is 5, this one's going to be like the most valid form of a power series. The further and further you get from 5, the less accurate it may be. And of course, we don't really know what it means by accurate right now, but we're just going to kind of talk about it in a general sense of the terms. That's the first type of question we sometimes see. The second type of question we sometimes see is, hey, does this series converge or diverge at specific values of x? Which this is going to turn into just like a problem we did on the quiz. Basically, the short version of it is plug in the x value, simplify it, and then justify it using any of the tests that you have ever seen. So when we're doing it with a certain x value, if you want steps, you're basically going to plug in the x, simplify, and then justify using any convergence or divergence test. And this is where basically why we did that whole first half of the unit. Like it could be just like a harmonic one. You say, hey, it's diverging because harmonic, or maybe it's an alternating series, or maybe you're using the ratio test or a geometric test, p-series. Any of those tests you've learned can kind of show up. So this is my series. I want to see if it's going to converge when x is equal to 4. So first step, let's just go ahead and plug in x is equal to 4. But when x is equal to 4, our series is going to become, I have x minus 5. Well, 4 minus 5 is -1 to the n. So I simplified it. Different tests we can use. I like using the most efficient one. What does that series look like? What type of series? Geometric. It is an alternating one, but geometric is a lot easier to justify. So I could rewrite it like this. And then we're going to justify it just like we did on the quiz. So we have the absolute value of r is equal to 1/3, which is less than 1. So it converges by the geometric series test. Again, what does that mean? When x is 4, this infinite polynomial is going to converge to some known function. What about when x is equal to 9? Again, pretty easy. Make sure you just plug it in and then simplify. 9 minus 5 is 4. This one again is forming another geometric one. And then identify the important parts. The absolute value of r is 4/3, which is bigger than 1. So it diverges by the geometric series test. Questions on that? So the other way this question is asked, and probably how it is more importantly going to be asked, is instead of testing it for just certain values of x, we just want to have like an entire interval. Like what intervals of x is this going to work for? What intervals of x is this not going to work for? And how that question might be worded would be something like this. For what values of x does the series converge? I do want to do a disclaimer here. When we're looking for the actual values that the series converges, I'm going to say, like, again, completely made up percentage. But 95% of the time, we are going to use the ratio test. And again, the ratio test is the one where we do the limit as n goes to infinity of a sub n plus 1 over a sub n. I noticed on the quiz that a lot of students are still having issues sometimes choosing the most efficient test. So for this one, what might be an easier test to use to determine that how often this was going to converge for what values of x? Geometric. Why are we using a geometric? This is basically a geometric series if you look at it. If I want to rewrite it to make it a little bit more geometric, this is basically the series. What is our R value? X minus 5 over 3. We know that we can rewrite it that way. So let's think about what it would mean if it's converging. If it is converging, what do I know about the absolute value of R? It has to be less than 1. And we just want to find the x values where that's going to be true at. So let's go ahead and just solve this algebraically. What might you do first algebraically? Different things. I might multiply by 3. Just get rid of that decimal. Like absolute value of 3 is 3, so I can take it out. So I have the absolute value of x minus 5. 3 times 1 is 3. And then we need to remind ourselves about solving an absolute value. Well, what does an absolute value do to a problem? It makes it positive. So if I'm dropping off the absolute value, it's either x minus 5 is less than 3 or greater than negative 3. And I can go ahead and finish that problem out. Solving for x, so I get x is less than 8, adding 5, or x is greater than, adding 5 is 2. What does that mean? Between 2 and 8, the series is going to converge. Questions on how I did that? I am going to add one word. I don't want to confuse us, but I am going to add the word potentially here because I know what we're about to do in like 2 more slides. And typically there's going to be a second step to this problem where we'd have to test the endpoints. Without getting into too much detail right now, eventually we would have to determine like, hey, is it also converging at 2 and is it also converging at 8? So we can kind of adjust those inequalities to be just less than or less than and equals to. Let's add some more vocabulary words. What do we call that interval? We're saying that basically between 2 and 8 that this series is converging. Which does kind of make sense if you look at what we just did on the previous slide. Like when we found x is equal to 4, we said it was converging. That is between 2 and 8. When we tried x was equal to 9, it diverged. That was outside the interval from 2 to 8. So that does actually have a special name. And the special name we're going to use for it, for what values does the series converge, that interval 2 to 8, it is called, nothing fancy, it is called the interval of convergence, which I think basically defines itself. It is the interval over which that power series is going to converge. We also have another definition, and that's going to be the radius of convergence. And the radius of convergence is basically 1/2 of the interval. So to go back to this problem, again, lots of vocab. We're saying that whenever x is between 2 and 8, the power series is converging. So we have, I think about a number line. What was the center of this power series again? 5. So like the center is 5. We're saying potentially it converges between 2 and 8. That represents the interval of convergence. Interval of interval. Let me try that again. Interval of convergence. Radius, kind of think about like the radius of a circle, half of a distance. The radius of a convergence is just half the interval. So for this one, the radius is going to be equal to what number? 3. So like the radius is 3, because from the center, you're basically going backwards and forwards by 3, and that's going to give you the radius. Big helpful form that I have found in these problems. I'm just going to call this like a helpful format. Is that if you're doing one of these problems, and you can get it in that form, x minus c is less than r, that c will always be the center, and that r will always be the radius. What do I mean by that? Going back to this problem that we did previously. Here's the line where I got it in that special form. So I have like x minus a number is less than a number. That 5 is the center, which we had already identified. And that 3 would then be considered the radius of convergence. Why is that a useful thing to do? It can basically prevent you from having to solve the rest of that problem. I think everyone in this class can literally think of a number in the middle and add and subtract from that number to find the interval. So again, if you can get it into this format, don't go any further from now on. Identify the center and then identify the radius. Questions?
I still think that the center is 5.
The center is not 5 hertz.
But like 3 is raised to the n power, so wouldn't we have to pull out the n?
But that 1/3 is the coefficients. Like even if I go through and wrote it out, like there's the center showing up in every term. That over 3 and is not where this is kind of be centered around. So, vocab, lots of vocab today. When it comes to the interval of convergence and the radius of convergence, all power series are going to have 3 options. Your first option is that radius convergence can be equal to a number. Those are going to be the ones that require the most amount of work to get the final answer. You could have a radius of convergence that is infinity. Or you could have ones where the radius of convergence is equal to 0. I'm going to talk about that first case first. It is the one that requires the most work to do. If your radius is a number, this will be one where like you have your center, you're going to go up by the radius and back by the radius. So then the potential interval is basically going to be that lower one, c minus r, upper one, c plus r. There's technically 4 possibilities here, because sometimes the endpoints will be included, sometimes these endpoints will not be included. So what do I mean by that? You could have an interval of convergence where both endpoints are not included. You can have an interval of convergence where both endpoints are included. And when I say are included, it means that it's still going to converge when you consider the endpoints. Or maybe, and this happens almost just as often, it's only convergent on one side of that interval, whether it's the upper one or the lower one. Second case, these will be the ones you like. If I say the radius is infinity, what do you think the interval of convergence is going to be? Or we're going to have to say this, how often is it going to converge if your radius is infinity? Opposite of never. It's always convergent. If your radius is infinity, then whatever your center is basically converging all the way above that and everything below that. What would be your interval of convergence? Negative infinity to positive infinity. Those are going to be the nice power series. That pretty much means that they always will work. And then what if your radius of convergence is just 0? How often is it going to be convergent? Not never, but just for that one value at the center. So the remainder of notes that we're going to be looking at is I just have 4 power series, and we're just going to identify the interval of convergence and the radius of convergence. This is a very, very common free response question on the AP exam. So common, in fact, I could probably almost guarantee that it will be on your AP exam, finding the interval of convergence and the radius of convergence. When you're asked to find the interval or radius of convergence, it kind of has a few main steps you want to look at. First step, you're going to use the ratio test. Or sometimes the geometric series test, but that's only on special occasions where that power series is clearly a geometric one. After doing that test, you're going to be able to identify the center and the radius. And then step 3, you're going to test the endpoints if needed. Sometimes it'll just be a step 1, step 2 problem. Sometimes we'll have a step 1, 2, and 3 problem. And so let's go ahead and look at examples. First one. We'll also kind of pay attention to what it's asking us to do. This one is asking us to find the radius of convergence. When you're doing these problems, and we'll see this a lot pretty much all this week, if we can easily manipulate it to be in kind of like a friendly form, then like you definitely want to kind of use that friendly form. This one though is asking us to find the radius of convergence. So first off, we want to figure out what x values are going to make this series valid for whether it's going to converge or diverge. Your options, most of the time it's the ratio test. Sometimes you can use the geometric series test. Looking at this one, are we going to be able to use the geometric series test? No, that n in the denominator invalidates it. It's no longer geometric series. So we do need to make sure we do the ratio test. Do need to make sure you show work appropriately. Some people got lazy on their quiz and definitely I took points off. But ratio tests, you always want to show what you're trying to find. You are allowed to jump into like where you've already like plugged it in, multiply by the reciprocal and line things up. So when I do the limit of a sub n over a sub n plus 1 over a sub n, I'm going to go ahead and set up my 3 fractions. And I have a sub n plus 1 divided by a sub n. And when I say divided by a sub n, same thing as multiplying by the reciprocal of a sub n. And I'm just going to conveniently line up all the correct factors. And then I just want to go ahead and take this limit. So this is the limit as n is going to infinity. Don't drop my absolute value bars. That first fraction, negative 1 to the n plus 1, divided by negative 1 to the n, what is that going to leave overall? Negative 1. Again, think about this. Could I write down just positive 1 right there? Yes, what's going to allow me to just write positive 1 there if I wanted to? It's an absolute value. So like I'm going to put negative 1 there, but do you realize those absolute values are still there? Looking at the second fraction, 2x minus 3 to the n plus 1 over 2x minus 3 to the n, what's going to be left over after simplifying? 2x minus 3 to the first, but 2x minus 3 times n over n plus 1. N is going to infinity, so what is that going to become? 1. When we're looking at this problem, some things I do want to kind of point out. We are doing the limit as n is approaching infinity. In that problem, n is the one changing, so you can't treat x like a constant. I know that feels weird, but we can treat x like a constant, but where n is the one that is changing. So I'm going to simplify this and kind of think about what the limit's going to go into play. Do I have any more n's left over in that problem? No. So if n goes to infinity, what's going to be left over? 2x minus 3. It is inside of absolute values. And here's how the ratio test comes into play. If this power series is converging, what would that limit have to be equal to? Or what should that limit be, I should say, not really equal to? It should be above 1 or less than 1? It should be less than 1. Guys, you got to know your tests to do this, so it has to be less than 1. And now we just want to finish out the problem. How do we finish out the problem? It's going to be helpful to us if you remember that nice, easy form. The absolute value of x minus c is less than r. So just manipulate it until you see that one. I have the absolute value of 2x minus 3 is less than 1. What can I do to get it into that friendly form? Take out the 2. Taking out a 2 is going to become 2 times the absolute value of x minus 3 halves, which is less than 1. Side the x minus 3 halves, which is less than 1 half. Why is that form necessary? It can kind of help us answer our question. It says find the radius of convergence. What is the radius of convergence for that problem? 1 half. So we know that the radius of convergence is 1 half. It didn't ask for it, but good to identify for practice. What's the center of that power series? 3 halves. Questions on that? So things I do want to say, so it's important for you to read the instructions. Notice this one did not tell us to find the interval of convergence, just the radius. So once I identify the radius, I'm done. I can move on to the next problem. How I could have reworded this problem, I could have reworded it, so same power series, but I could have said, find the interval of convergence. In grading AP exams, the most common mistake people forget is you must always check your endpoints when you're trying to find the full interval. So step 1, we would do the ratio test. I'm not going to redo doing the whole ratio test, but we basically got down after the ratio tests. We had this x minus 3 halves, which is less than 1 half. This question is basically asking us to find the interval of convergence. We're basically trying to find what x values would allow this power series to converge. Here's what's kind of going on in my head. Whether you draw it down or not, it's kind of up to you. This power series is centered at 3 halves. We know that the radius of convergence for this is 1 half. So if I go up and down by 1 half, 3 halves plus 1 half, 4 halves, which is 2. 3 halves minus 1 half, 2 halves, which is 1. What we are trying to find out is there's right now 4 possibilities for the interval of convergence for this problem. You could have an interval of convergence that is going to be between 1 and 2. You could have a closed interval where 1 and 2 are included. Or maybe the 1 is included and 2 isn't. Or maybe the 1 is not included and the 2 is included. We need to figure out which one of those is correct. Well, how do we do that? We just want to test the endpoints. How do we test the endpoints? Just plug in those x values, simplify, and then justify it as a new series. So we're going to test our endpoints. One endpoint is when x is equal to 1. Another endpoint was when x was equal to 2. Let's plug it in and simplify our series. So I have the series. This is -1 to the nth. 2 times 1 is 2, minus 3, -1 again to the nth, all over n. I want to justify that series. It's kind of ugly with having -1 to the nth and -1 to the nth. But those do have the same base, When I have the same base, what can I do with the exponents? Add them together. That's going to become -1, n plus n is 2n. Well, if I have 2 times n, is 2 times n always going to be an even or an odd number? Even. If I have -1 raised to an even number, what is it always going to be equal to? It's just 1. Other way to think about this, if you kind of split up the exponents, -1 squared is 1, and then you have 1 to the n. What's 1 to the n always equal to? 1. So like basically that whole series is going to simplify to 1 over n. What can we say about that series? It diverges, so the series diverges. Why? It's harmonic. What can we do with that information? Already we know that 1 can't be included within that interval. So we know it's not going to be those 2 options I just crossed off. And then we want to do the same thing now, but for the other endpoint. The other endpoint, again, is x is equal to 2. Plugging it in, so I have -1 to the n. 2 times 2 is 4. 4 minus 1 is 1 to the n over n. Looking at that 1 to the n, 1 to the n is always going to be equal to what? 1. So this series is just going to simplify to -1 to the n over n. And then you want to justify that using any rules we have. But what do we know about that series? It's one of our memorized ones that we should have memorized.
Oh, that's the alternating harmonic.
It's the alternating harmonic, which is what? It's convergent. Memorize that right now. Alternating harmonic is convergent. So when we talk about the interval of convergence, we know that 2 is included. So the interval of convergence is -1 to 2, or you could also write that with the inequalities. 2 is included, the 1 is not included. Again, often that's an AP question. On the free response exam, each free response question is worth 9 points. Often going through all that is worth 5 out of the 9, which is easy stuff to do to earn a lot of points on the AP exam if you know what you're doing. Questions though on that problem? Let's do one more and I'll save the rest for tomorrow. Another power series. We want to find the radius and interval of convergence. So like several things it's asking me to find. We need to find basically how far away from the center is this potentially going to be convergent. And then if the radius is a number, go then and test the endpoints to see whether they are included or not included. When you see a problem like this asking for the radius or interval of convergence, what test are you most likely going to start off with? Ratio test. Sometimes you can use the geometric one. I automatically see a factorial there, so not a geometric one. Don't be lazy. Let's go ahead and write out the limit statement. So this is what we are finding. Plugging it in. A sub n plus 1 divided by a sub n. And then we can simplify it. N plus 1 factorial divided by n factorial is just going to give you what? N plus 1. X plus 2 to the n plus 1 divided by x plus 2 to the n is just going to give you what? X plus 2 to the first, but x plus 2. And then now we want to take the limit of this. Now n is going to infinity. So if n is going to infinity, what is that expression going to go towards overall? Infinity. So it's going to be infinity times x plus 2. Well, this going to infinity, yes, the limit is d and e, but what's important about that is greater than 1. So the limit is D and E, but basically it's because it is infinity, which is not greater than 0, greater than 1. And that will be true always for the most part. So like it does not matter what x is, that limit is always going to go to infinity, except for one x value. What one x value would prevent that limit from going towards infinity? -2. Why would -2 prevent that from happening? It becomes 0, which is not an exciting series. If x is -2, what basically is that series going to be? 0 plus 0 plus 0 plus 0 plus 0 plus 0. Not exciting. So basically, if I'm answering this one, if my limit is going towards infinity, and this limit is always greater than 0, which basically means that it is never less than 1 except for a certain value, what's technically the radius of convergence for this problem? So you have two options. Is the radius infinity or is the radius 0? 0. There's less options where this is happening. So the radius is 0. Don't need to test the interval for this one, so they're not really endpoints. But what's the interval of convergence for this problem? -2. There's just one value for x where this series converges. It's not an exciting value for x, but it is -2. Didn't ask this question, but kind of a good question to ask. What would be the center of this power series? -2. So it is centered at -2. Which again, we could have identified that because this one is kind of written in that friendly format where we have the a sub n times x plus c to the nth power. So we could identify the center without having to go through all that process. I'm going to stop there for today. We do have a few more problems to do, so I want to do at least one more example where the radius was infinity, where it's basically going to be always convergent. And I have another example where we just have to go through and test the endpoints. That's ultimately going to be a pretty important skill to have. Assignment-wise, what you can be working on. So you have homework 7 that you can begin working on now. Make sure you just answer the question asked. Some of those questions just ask for like the center, some ask just for the radius. The ones that will be the most work are the ones that ask for the radius and the actual interval of convergence. Look over your quiz. Definitely reach out to me with questions you have on your quiz. Tomorrow we are going to finish up these notes, and I'm probably also going to start introducing these things called Taylor and Maclaurin series. But that's basically what we're going to be looking at all this week. It's kind of these power series, these kind of weird infinite polynomials. Thursday and Friday is virtual for everyone. We'll be using the URL schedule, so those periods will be a little bit shorter. And for me, those classes will be synchronous. You will log on during class time to view the notes. The test for this unit is basically going to be, and I know it's not the ideal day, but it's going to be that Friday before spring break. So y'all can go ahead and get started on that homework. I definitely suggest you start the homework, make sure when you're checking your